Thank you, Pete. So yeah, so Michael and I are going to cover off a few things, basically set some context around security and security within a multi-tenancy environment, and what multi-tenancy means. And I think within the construct of multi-tenancy, it can mean a lot of things. So it could be for an ISV, it could be different customers. For a line of business or a large business, it could be different business groups. Or for a large multinational, it could even be separate organizations that are all trying to be under one umbrella. However, the problem and the mechanisms for actual security within the cloud and across different environments all fits into a very singular pattern. And so what I want to do first is set some context. And so I'm going to talk about the workflow for Vault and just establish what that workflow is and why it's important in terms of the context of what we're talking about. So Vault works off this element of zero trust. And that word's been thrown around a lot. US Defense have come out and said it's this policy that everyone has to take. There's a whole bunch of hype around it. But fundamentally what it is it's making sure that you can identify who is doing what. And so for the workflow in Vault, what we first need to do is log in and generate an identity token for that client. Now in Vault's workflow, that client could be a human, it could be an application, it could be a machine, but regardless of that element or the what, it's a thing, it's a who. And that who needs to be identified so that we know that they are who they say they are. And that can be done against a whole bunch of different mechanisms. We have a provider, authentication provider plugin mechanism where we can plug in different elements that are have native interactions. In this case, for example, we could be using Azure AD. That could be username and password, could be a whole other scope of elements. But once we actually have that known source of truth that we can authenticate against, and that actually validates that the user is or the client is who they say they are, we then create a token. And that token becomes important because now we have a unique way of identifying that client. When that client then wants to interact, so when we start doing some of the secret management elements, it uses that token to actually say to Vault, this is who I am. And Vault then can say, well, we're going to let you go and create a secret. We're going to let you go and get a dynamic secret. We're going to go and let you get a PKI. We let you get a certificate. But all of those things are done because we now know who you are. But as we start to expand, you'll see that that's great. But how do I then put finer controls around that? Because if someone misuses that token or gains that token, how do I make sure they don't start changing it? Well, and this is where we then have the ability to attach policies. And a policy then says or uses the CRUD, so create, write, read, update, delete, and allows you to actually then put context around what that known entity can then do against that endpoint. And so there are additional mechanisms, particularly as you move into the enterprise features. You can apply Sentinel policies, there's app roles and other elements. But fundamentally, we have a policy approach. We have an identity. We have to use that identity to be able to do something. And to do something, we have a policy applied to that puts control in place. Now, I mentioned secrets management. In the use case that we're going to be looking at secrets management, we're just using a simple key value pair. But secrets management is fundamentally that concept of a key value pair and pulling it into a central location. The reason that you want to centralize it is obviously it creates an easier place for distribution, creates a singular point of control, you have a standardized set of policies, and you can actually now have audit and insight into what is happening around your infrastructure places. Now, the challenge happens, obviously, that's a challenge regardless of whether that's across multi-tenancy or even within a single instance. But those challenges are the same regardless of the different platforms. You need to solve for and understand that challenge around secrets management, whether that's dynamic secrets, so the ability to create a secret with a defined time to live around it, or whether it's a static key value pair that you're using as a as a unique identifier within a particular application, for example. But having that under a central point of control means that you can now deliver a standard approach. And again, particularly in the context that we're talking about across multiple platforms, having a standardized approach means that there's less risk of error in having to understand lots of different environments and different ways and approaches to solving that problem. Now, Vault uses some fundamental principles. The first of those is that it's API driven. This means that in terms of the new world where applications are moving towards this API as a first-class citizen, scalability and the ability to interact with an API interface becomes really important. And Vault scales to a massive scale. You know, Adobe is doing something like 800 million transactions a month or something crazy through their Vault instances as part of their security infrastructure. And that's a public reference that we've had at some of our HashiCorps. So that ability to scale, that ability to understand and deliver those types of secrets within that level of scale means that within a multi-industry or across different platforms, you can actually scale out to solve for your secrets management challenge. One of the other key principles is obviously that ability to use any identity. So obviously being able to plug into lots of different identities and make it easy to use. Ease of use means that it's adopted easily. And again, that ability to extend and integrate with, you know, so like the Azure platform or SQL Server, that ease of integration, there are standard plugin modules that allow for that ease of integration. And again, generating that acceptability, and the easier it is to adopt, the easier it is that people, or more likely it is that people will not try to navigate around it. So if we take those concepts and then look at that within the context of the multi-tenancy environment, we put that into some real terms around thinking just for a database, for example. In a single tenant, you're going to land up building for environments, you're going to probably land up building complete silos. Obviously, this has great separation between those tenants, but the cost and complexity is an X factor multiplier by every tenant that you then add into that environment. It becomes a lot more complex, becomes a lot more costly, and obviously the chances of risk increase as you increase your your infrastructure profile. In a true multi-tenancy, there's a couple of approaches that you can do. So you could have a single database and then actually have multiple schemas. Each tenant then has its own schema within there. But then the challenge with that is how do you make sure that a tenant can't get access to one of the other schemas? And if they do, how do you protect that data within that schema? And this is the model that we use in our demo, and we'll show later. The other one is obviously where you just have a single schema and you bang everything into it. That is obviously, you know, scalability and from a delivery perspective is probably the easiest. But then you have, how do you separate that data? How do you encrypt it? How do you make sure that there isn't any overlap? And so again, those elements around how do you make sure that your data is secure? How are you making sure that you have access to unique certs for each of your tenants? And how do you make sure that that can be used easily and adapted quickly, so that if you do take on one of those models, you are actually looking at applying it in the appropriate model. So if someone does actually get the token, an access to that, they don't have the right key, and therefore they can't dump databases and see other records. So all of these things are factors that you have to think about and solve for. And so what can you use to try and solve for some of those problems? And so Vault Enterprise has some mechanisms built in that you can leverage that actually help you do this. The first of these, and probably the biggest concept, is this concept of namespaces. So namespaces basically allows you to create vaults of vaults. So it gives you, it's this concept of a vault within a vault. So you have the parent, and then within that you can create subsequent namespaces. Those namespaces are completely unique, and then within that namespace you could subdivide again. So you have this ability to create completely overlapping elements. So that could be, dev, test, production. You could have the same endpoints, you could have the same naming structure, but completely different elements and permissions in each one of those namespaces, thus giving you the ability to experiment, fail fast, but keeping the security segmented across those different environment types. Also, Vault has the ability to use, using our transit secret engine, a single API call to encrypt data. So in that concept of the shared databases and shared schemas, now your application can run data through Vault, run it through the transit engine, encrypt it as a single API call, and push that out into your storage mechanism. So now you do have an easier or an ability to use an easy mechanism to create that uniqueness in not only the data stores, but also the keys used for each one of those transactions. So each tenant would have their own key. They could run the data through it. It goes into a mixed database. Doesn't matter if someone dumps the entire database, because each key is unique and they couldn't see that data. And another important factor is obviously the ability to track that unified identity. So because we have that zero trust model where we identify with a token, we now can track that entity across different mechanisms that they need to gain access to. We know who they are. We can set different privileges and mechanisms across that. And now we have a single source of truth controlling a single user and what they have access to. And again, simplifying that process so that everything is centralized, everything is tracked, everything is auditable. So if we just expand that into kind of a use case and a basic scenario, what we're really saying is within Vault, you have the abilities to create these three different business units, for example, or that could be tenants, could be different organizations, different companies. But for this line of conversation, we call it business units. Within that, you can set up, a separate line of business within that, or team structure, and then under that you have separate individuals grouped within that. Each of them have different permissions. Each of them have different access. Now, users could be in different teams. They could be in different sub teams. They could be in different business units completely. But within that structure, they would get different permissions and different access rights depending on how they log in across those mechanisms. And so that's really allows you to create that really flexible environment around how to deliver those scenarios. So now I'm going to pass it over to Michael to actually talk about that concept and how Vault could be used within the Azure environment.
Perfect. Thank you, David. Just want to switch gears slightly here and talk about multi-tenancy for SaaS providers specifically. So when I talk to customers about this, the first question really is why? Why multi-tenancy for SaaS providers? So this model is normally more attractive in generalities because of the lower cost to operate a solution when compared to something like a single tenancy model. Because you're using shared resources and shared platforms to house all your customers onto it, it's generally more attractive from a run cost perspective. Now, even if you have a tiered approach, and what I mean by a tiered approach is where each of your customers buys a tier of your SaaS product, maybe it's basic, standard, premium, even if you can co-locate all those basic customers on shared infrastructure or platforms within the basic tier, that's generally more attractive from a run deployment cost than having a single tenanted resource model. So what are the risks? So for me, there's two significant risks when we're talking about multi-tenancy for SaaS providers. The first one is scale, and that's kind of a two-dimensional problem. We're talking about scale both from a platform perspective, but also from an individual tenant perspective. So when I talk about a platform perspective, it's making sure that your shared components or shared infrastructure that run all of your tenants has enough capacity. And we'll talk about a little bit in the next section. And then from an individual tenant perspective, we've all probably heard about the noisy neighbor effect in cloud. So we need to make sure that our tenants are, isolated and protected to make sure that they're not interfering with each other. But the biggest one for me, though, is tenant isolation and separation. So when we all buy SaaS products, we have the expectation that our data won't be, misused, or it's leaked into another tenant and the other customers or tenants are seeing our data. We all have the expectation. So as a SaaS provider, that's like the biggest thing you need to think about when providing a SaaS platform to your customers. Next slide, please, David. Perfect. Awesome. So I want to talk about Kubernetes because Kubernetes is one of the most popular compute platforms at the moment. And Azure has a highly available, secure and managed Kubernetes service called Azure Kubernetes Service, or I'll be referring to it as AKS. So at the bottom of the page there, you can see I've got a link there, which is the AKS best practices for cluster isolation. And that document talks about kind of two primary ways where you can isolate workloads or tenants on AKS specifically. And those two models are logical separation and physical separation. But today I'm really going to explore the logical separation aspect. So in the diagram on the right-hand side, you can see a Kubernetes cluster there. See where it says team 1, team 2, and team 3 in the context of a SaaS provider. Think of them as customers. So customer 1, customer 2, customer 3. And the way it works inside of Kubernetes, it uses namespaces as the logical isolation boundary for workloads and resources. So why do we normally go with this model? The reason there being is logical separation of clusters usually provides a higher pod density than physically isolated clusters with less compute capacity sitting idle in the cluster. So when you combine these things with things like the Kubernetes cluster autoscaler, you can then scale the number of nodes up and down to meet demands of your SaaS customers. The best practice approach to autoscaling minimizes costs by running only the number of pods or nodes needed at any one time. So Kubernetes has a number of different ways of auto-scaling, and it's really a really cool way and a really good way for SaaS providers to make sure you're using the capacity that you need at one time, but also kind of de-risk one of those risks I talked about earlier, which is the scale perspective from the platform perspective. Cool. So now we have an AKS cluster up and running using logical separation with our workloads using namespaces. So how are we going to do secret management and get all that goodness David was talking about earlier, with the secrets management dynamic or if it's static. Cool. So how are we going to do that? One of the ways there is using HashiCorp Vault. So not to steal David's thunder because he'll be doing this a bit later, but using namespaces both in Kubernetes and HashiCorp Vault is a great way where you can do that as a SaaS provider. Next slide, please, David. Cool. I also wanted to kind of take these concepts and apply it to the data store perspective. So inside of Azure, we have a really great number of great options for storing data. And today we're going to be focusing on MySQL. So in Azure, we have Azure Database for MySQL, which is a managed scalable MySQL database as a service offering running inside of Azure. So Azure Database for MySQL already has a lot of really good built-in features that you can use, like firewall rules, enforcement of SSL, TLS, and data encryption with customer managed keys. So that's all built in and available out of the box. But when working the data, and I've got a link to the shared responsibility website there, it's critical to understand the shared responsibility model between you and your cloud provider and what security tasks are handled by the cloud provider and which tasks are handled by you, the customer. So if you go to that link, if you look at all cloud deployment types, whether it's IaaS, PaaS, or SaaS, the customer is always, you own the data and responsible for protecting the security of your data. So therefore, as a SaaS provider building a platform on Azure, you're responsible for protecting the security of your client's data because you built that platform inside of Azure. So like I said at the start, one of the biggest risks in my mind for a SaaS provider is using multi-tenancy and how you can separate or isolate your customers' data tenants from one another. So again, how are we going to do this? One way is using HashiCorp Vault. So again, David spoke about this a little bit earlier, but you can use HashiCorp Vaults and its namespacing technology to encrypt each customer's data separately using a separate key. Therefore, when I talked about before about customers' data potentially bleeding between tenants or being presented to the wrong tenant, if they're encrypted with a separate key, that should prevent that from happening. And again, not to steal David's thunder because he's about to do a demo. So I'll be passing it over to you, David.
Sure. Right. So this is kind of a little bit sideways of the topic, but we're going to build and run this environment from Terraform Cloud. But it is important because one of the concepts that we have here, we can see that this environment actually isn't built at the moment. It's linked, however, as you can see here, to this repository. So if we go into this repository, let's make an edit change here. Let's just enable the enterprise version, for example, and we commit this into this repo. Now, hopefully we've made a change there. If we go back to our Vault, we can see our Vault. If we go back to our Terraform Cloud, you can see now that we've actually kicked off a plan and apply. So this is actually by making a change within our repository. It could be a commit, could be an edit change, could be adding in of a different customer. We've now created a mechanism that's kicked off a build. So if we look at that build process going through, we see that we have our plan. It's going to actually build all of this infrastructure elements. We're putting some cost estimation in place. So we're actually going to run through and use Terraform Cloud to do a cost estimation. And more importantly, and this is why I wanted to show it, we're doing some policy checks. So simply from committing code into a repository, we've now defined that it's passed a whole set of criteria, which you could leverage something like the Center for Internet Security defined policies that we have. So our Sentinel policies, which is what these are based on, giving you best practices before you actually go and confirm and apply and build this. So why is that important? Well, it's important in terms of that how do you do security across multi-tenancy, because now you have a simplified mechanism that can be used to make just a code change, which then establishes a build process that then builds out that environment. And to Michael's point around looking at how we establish all of these different criteria. So here we're going to build a Vault cluster called Tiger, cool name. We can see that simply by leveraging that that concept of a simple commit, we've now gone from just committing code to building infrastructure, deploying, creating random names, using Helm to deploy that infrastructure and tying it into our mechanism. So we've simplified, and again, by simplifying it, the more likely it is, or less likely it is to make mistakes. Therefore, you're increasing your security. So let's just take a look, and we're going to use. I'm going to use Cloud Shell. Now, Cloud Shell is interesting in that from an Azure perspective, you actually do have Terraform, which is where that code that we just looked at here is based on. And that's built into the Terraform Cloud Shell. So you could actually, if you wanted to, you could clone that repo and run it directly from a Cloud Shell environment. So you could stand up and run that code directly from here. We obviously, or I obviously for this demo purposes, are leveraging Terraform Cloud to actually give us some of these benefits around the environment and policies and being able to do cost estimations. But if you wanted to run it, you could run it natively straight out of that Cloud Shell. Michael, do you want to mention how you use some of the Cloud Shell, for example, while we just wait for that build to go through?
Yeah, absolutely. So you're probably noticing that David's using the Bash version of Cloud Shell. It's probably no surprise to anyone that I prefer the PowerShell version. So you get two flavors of the Cloud Shell there.
Let's not get religious.
Exactly right. But the good news is you can use, either of the two options and they work just as great. So yeah, it's really been aimed and designed for interactive kind of workload. So it's not kind of designed for you running a Bash script and leaving it there for hours on end. It's really for you to spin it up, run some commands and spin it back down. Another cool feature that I personally use a lot is you're able to attach Azure storage to it as well. So every time you're spinning up or spinning down these Cloud Shells, you can save, like David said, Terraform, or you can save any type of artifact inside Azure storage, and it'll be there next time that you spin up or spin down the Cloud Shell. And
yeah, I think one of the things that I like for example, within this environment, let's take a look at this this script that we'll use. You can actually it has a built-in code editor within it, so it obviously makes it really easy and friendly to use. And again, when this environment builds out, close the editor, we'll take a look to see if this is now built. Still creating, but within the Kubernetes environment, hopefully we stood up and you can see we have. Do we have Tiger yet? If it does, there we go. So one of the reasons that I like using the Cloud Shell is it makes it really easy to connect. So from here, all we'd have to do is grab some basic details, stick it into our Cloud Shell, and we now have effectively access into our Kubernetes cluster. Now, obviously, that you can do this from your local your local machine, but I find it really easy and quick and friendly to be able to do that And obviously you can establish your, your alias commands. See if the pods are up yet. Still have that one creating. So obviously this run's still building out. That's created. So hopefully this should be stood up there. There we have the running environment. Let's take a look at the service address. So this is the Vault front door. Let's just take a look at that UI. We're using the standard port for it. So what you have here is basically Vault Enterprise in a uninitialized state. What that means is that Vault is sealed. So again, I said it was Vault is based around that API architecture. Let's just kick off that build while I talk about this. And so you have that you have Vault in that environment that is sealed. And what that seal means is you have to unseal it, which is the process that we're running through here. That creates a root token. That token is used to unseal. So you can see here how we've unsealed, initialized Vault and then unsealed it. So sealed is false. So it's actually unsealed it. We now have an ability to create unique tokens. So these tokens are being created uniquely for those individual namespaces. We're creating individual namespaces across those environments. And for each one of those, we could create a unique token. For the purposes of this demo, we actually create a shared token, but you can do multiple users, as I said in that diagram that we talked about, breaking up those tiers. This is establishing Vault, is creating out the database. You saw earlier that we stood up and defined our MySQL service, and we deployed a Ubuntu image as well. So this is building out and creating our unique environment. It's writing to leveraging and writing to our namespaces within it. And I suppose the important thing to think, or the important thing to understand, and we'll have a look in a minute as this builds out, is that within that Vault environment, you can now see that you can actually have a unique namespace. So all you need to do is we need to get our token, which once this runs out, we can go back and grab our token. Which token? There we go. We can grab our token, and we can now access our Vault environment. Within that environment, you can see we have got an app name, and within that app name, we have an element that is making it unique. So again, in a multi-tenancy component, you could use the key value store not only as a username password, but as any data point. So you could put in anything into this that you want to retrieve that makes uniqueness around that multi-tenancy environment that allows you to then scale out those elements. If we just grab and jump onto our Ubuntu image, what we can do within our environment, hopefully we're all finished building now. Yep. Okay, get files. Yep, Ubuntu is running. We put this into here. Jump onto our Ubuntu image. Yeah. So now we've actually jumped onto that Ubuntu image running in our environment. Just need to do a few interesting updates just to get it up to speed. Obviously, if this was in a working environment or image, you could script this, but for the sake of this demo and because my scripting sucks, I can just do it this way. Put in some JQ just to make it pretty so that everyone can see what's happening. Put in JQ so that makes it pretty. Let's grab our token that we need to define for our environment variable. That goes into there. Let's go back and grab that token. Sorry, roll in. There we go. Our token. Yep. That gives us our access token. This is obviously identifying that client. So again, that zero trust element around how do I uniquely identify that that client and making sure that the client can actually gain access to it. So if we now pull out our data, you can see that we've gone to the other endpoint. So we're at the same name, same definition, but we've used a separate namespace. So the app2 namespace, and we've pulled out that secret and key value pair, which on, as we showed in from here, we have app1. So you have, again, you have within the structure of those namespaces, you have that uniqueness to be able to define different key value pairs. So if we just take that to the next level, you can see that if we jump into our deploying our apps, for example, so if we just jump into our app, we could actually have two completely unique, well, two apps that are the same but fundamentally different across the customers. So they are the same app, but they're being deployed in two different tenancies. So if we just take a look into that one, so let's use that cool feature that that I was talking about in having a code editor built in. So now this is our code. If we look here, we have our access token that we obviously used earlier. This was an older one, so I've just replaced this with the new token. Oopsie, not that one. I have to get a token. What eyes can see. There we go. Grab that token. Add that into the code here. Save it, which is a bit I always forget to do. And now from here, we can see the here, and now we can deploy this using a standard Kubernetes. One. And if all my cutting and pasting is actually being done correctly, service, we can see that our app has been deployed and is waiting an image. So let's just jump into that transit app 2. So go again, let's just change that, add in our token. Again, you can see that that was the old token here. Just change this. Save it. Then close it, which is always the way I always get it around the wrong way. And again, we can effectively where are we? Yep. App 2. And so now we've deployed app 2. So if we just service, we have, there's our original app. Here's the one we've just deployed. Let's take a look at that app first. So here you can see we have our application. You can see that it's being processed by app 1. And if we take a look at the database view, you can see that you have a dynamic secret that we've used to actually access that database. So if we take a look at the records that are used, pretty standard. Let's add our own record here. So just put me and last name and so if we now look at our database view, and if we dump in our database, you can see that we have actually this is the first version. So we encrypted with Vault. This is the first version of that. And we have a unique encrypted string across that. Now, if we just go back to our environment here, hopefully this one has now come up for work. There we go. So we have our second app. Now you'll see that obviously this app looks and feels very similar. However, we see we've got app 2. If we take a look at our database view, we don't have that record that we just added. If we added our records here, let's make the wife famous. We can see that we now have, from a database perspective, first version, different key strings, different mechanisms. Now, if someone actually did the database, those strings would then be completely unique within those two environments. So going back to basically what we're talking about, you can see that by leveraging Vault in the environment, you have an ability to create uniqueness. You have the ability to use namespaces. Just the namespaces that within Vault is obviously a different structure from the namespaces in Kubernetes, but the concept being the same, ability to create that environment within an environment and create uniqueness within it. Even though they're the same endpoints and same names, you can apply policies to that. So you can define what different access rights. You can apply different tokens, so different access and different users can gain access to different applications. And if anyone compromises those elements and does do a database dump, you can use unique encryption strings to make sure that no one has those keys. With that, I thank you. I thank you for Michael for his time, and over to you, Pete,